more or less recorded.
Thanks everyone for coming. For those of you who are new to PyDiff, welcome. After this, we're probably going to go to a pub and talk, I guess. But the first talk this evening is by Martin, who will just take it away.
Yeah, so I'm gonna do a quick talk, hopefully it's quick, about what Python teaches about beer. So fair warning, this talk will contain alcohol. So, if that causes any issues for anybody, you might want to maybe put your headphones in and have a nap or step outside. Also fair warning, I have consumed some alcohol today. It was my staff Christmas lunch, so I have been drinking since midday. But I've been very sensible and, you know, kept it fairly light, except for when a certain somebody, thank you Ian, kept buying me beer when I said, no more beer, I've got to talk at PyDiff tonight, I don't need any more beer. And he kept coming back to the bar with more and more beer. Which is fine, because I do drink some beer on occasion. I like a lot of different types of beer. I like ales. I like all the different types of ales. The English ales, the American ales, the Irish ales, the Scottish ales. New Zealand ale today had a New Zealand IPA. It's very nice. I like the stouts. I like the porters. I like the lambics. I like the sours. I basically drink quite a bit of beer. I don't think it's an unhealthy amount of beer. My wife might disagree. I think it's okay. One of the problems you have when you like beer is that there's an awful lot of it out there. It really is. I mean, the number of breweries that are around today has kind of exploded. You know, you can walk into any decent bar and find a good selection of beer. Incidentally, not the bar that we went for our Christmas lunch today. They do not have a decent selection of beer. Stay away from 29 Park Place if you like good beer. We're broadcasting this live, and I'm just very negative about it. Sorry, the food was okay. So the problem is that you drink a lot of this beer, and you kind of don't remember what it is, right? So fortunately, as with everything, there's an app for that. There's an app. It's called Untapped, and it's essentially Foursquare for beer. And if you don't know what Foursquare is, that's where you can check in when you go places. So whenever you go somewhere, you check in and record that you went there. Untapped is like that, but for beer. So whenever you drink a particular beer, you can check in that you've had that beer. And you can say where you had it. So this is my profile page. 2 hours ago, I had an Oh Ho Ho by Otley at the Penwick. It was okay. I gave it, 2.75 stars. Earlier on, I had a Christmas Truce by Grey Trees at the Penwick. That was a little bit better. So this app allows you to kind of log what you're drinking, where you're drinking, when you're drinking it, give it a bit of a rating. You can actually add a little review if you want that people can see. You can add a photo if you want to. And this is a whole social network. It's a whole location-based social network based around beer. So you can make friends with other people and you can see what they're drinking and what they've rated. You can give them a little cheers, which is their version of Facebook likes. So you can toast people's drinking. It's a wholly irresponsible app because it encourages massive amounts of drinking. They give you badges for drinking more beer. And the more beers you drink of a particular type, the higher level a badge you get. So, you know, there are some ethical issues around it, but I love it. And what I really like about it is that there's an API. I'm a computer scientist. I love being able to get my hands on data. I now have a rule that I won't sign up for a service if there's no API. If there's no API, I'm not giving you my data because I want to get my data out because the things I can do with my data are far more interesting than the things that you can do with my data. I'm still smarting from Letterboxd, who have now been promising me an API for 3 years. I even paid for a pro account on that site, and they didn't give me anything. But Untapped has an API, and it's actually quite nice. It's very simple to get hold of some data. If I have here a simple Python notebook, and if I was to do something like r equals requests.get, give it a URL. This requests, by the way, is a really, really nice Python library for doing this kind of stuff online. If you're ever making requests to APIs or to web servers, requests is really nice. It totally beats URL-lib, which is frankly shocking. URL-lib was bad in Python 2, so then they combined URL-lib and URL-lib2 for Python 3, and they still didn't get it right. Requests is URL-lib done properly. So I can call this URL, but I need to give it some parameters. So I need to tell, essentially I need to tell the API what I want. And what I want, oh, I'm in the wrong box. What I want is all of the beers that have been drunk in a certain location. So I can give their API a latitude of 51.48 and a longitude of minus 3.18. That shouldn't be in the string. And I can give them a radius of 10. And what I'm essentially doing is telling the untapped API, I want to get all of the beers that have been drunk within 10 miles of this particular geographic point.
51.48 comment. Sorry.
Thank you, Christopher. I will rely on you for spotting all of those mistakes for the rest of the evening. And I can identify myself, client ID, which just happens to be my API key that lets me access this data. Anyone can sign up for an API key from
Clients.
Yeah, thank you. I've spotted that one. Anyone can sign up for an API key. They're actually manually approved at the moment, so you need to tell them that you have a good reason for wanting an API key, but you can tell them anything, and they'll pretty much approve it. So I'm asking for all of the beers that have been drunk within a 10-mile radius of this point. Does anybody recognize this point?
Here?
Right here, Cardiff. Yeah. All good Cardiffians should know 51.48 minus 3.18, pretty much the center of Cardiff, somewhere around the castle. So I can pass these parameters to my request, and then from the request library, I can ask for the JSON response. And what's nice is because they give me a JSON response, the data that I get back is really easy to deal with. It's not like they're sending me back XML that I have to, pass into some sort of tree structure that's going to be a massive pain. XML's horrible. JSON's lovely, and Python is pretty good at dealing with JSON. So essentially, this is going to give me back a bunch of Python objects that I can deal with. So let's have a look at the whole response. Hopefully this is going to work. There's probably going to be some typos that we haven't spotted. No, there we go. So I've got the response back from the API. 200, took 0.478 seconds, great. I've got 25 check-ins. So I have now got the most recent 25 check-ins within 10 miles of the center of Cardiff of beer. So the most recent check-in is somebody checking in Pale Ale Australia by Viper and True, good brewery. They haven't said anything about it. They checked it in at 7 minutes past 7, so about 5 minutes ago. They gave it 4.25, so could be a decent beer. It's someone called Rhiannon. They haven't added any further details, and they were at City Arms, Cardiff. Okay, so we can see a huge amount of data about what's going on this social network, and we can get quite a lot of information. So we know that City Arms is apparently a nightlife spot on Key Street. We can go down to the next one. The next one was something that requires a character in Unicode that obviously Python can't deal with.
So crucial, it's judging its check of Polish.
Thank you. Which was checked in 2 minutes past 7 by Richard in, where are we? We are at
10 feet tall.
10 feet tall. Okay, yeah. Yeah, 10 feet tall, Cardiff. Okay. So we can get a huge amount of data out of this API. So we could call this API every minute, every 2 minutes, every 3 minutes, and we could get pretty much all of the activity of the social network within Cardiff, right? And I've done that, and I'll talk about that a little bit later. But what we could actually do is go further than that. And that's where these guys come in. This guy, Matt, sadly not with us this evening, realized that with the monitoring code I'd done in Cardiff, we could take that further and we could expand that out and we could look at a bunch of different places. And while he was at a conference with this guy and this guy, and they were in a bar, which is where all good ideas come from, they realized that maybe we could monitor Untapped and we could get some actual research out of this. We could combine our combined love of beer with data and get some research out of it. And it would be very easy because we could just do a whole bunch of monitoring with the code I already had that monitors various places, do a bit of analysis, and then submit a paper to a conference and hopefully get a nice free holiday somewhere, which is what we did. So we spent a couple of months at the end of the summer putting a paper together. We submitted it to WWW, which is in Montreal next year, and hopefully we'll get the notification this evening that we're all off to Montreal. And if not, we'll find somewhere else in another good location. We'll submit it. So we've been working on this data, and what you can actually do is you can get a huge area of data from the API. You can say to Untapped, give me everything within 25 miles of a given point. Okay, so we can say, give me everything within 25 miles of the centre of London, and we essentially get all the beers that are checked in on Untapped in the whole of London. We can do the same in New York. Okay, this is quite a large area. So that's what we did. We took a whole bunch of cities, and I'm going to do some live coding in a minute to analyze this, but basically we monitored 40 different cities. We picked 34 in the US, 34 US cities based on population, 6 European cities. I'd like to say it was more scientific than on a whim, but basically it was on a whim. And we monitored them from the 13th of August onwards. Okay, so I planned this talk around this data over the last couple of weeks, but it was based on the data set that I pulled down from the server that was doing all the data gathering a while ago. And then what I did this afternoon, while I was out at my Christmas party, I thought, I know, I'll update the data. So I pulled down the latest data set and analyzed that. So I've got a talk planned around what the data was, and what I'm going to do now is some analysis of what the data actually is, and hopefully there's not going to be too many changes. Otherwise, this is going to get slightly skew-if. So, first of all, I've cheated slightly because analyzing this amount of data does take a while. So I have run a whole bunch of code beforehand to read some of this data in, but I will talk you through it. But first of all, I'm just going to look at how big my data set is. So we're running from the 13th of August. We're covering 40 cities in the world. Would anybody like to hazard a guess how many beer check-ins we've seen? People who were in the pub earlier cannot answer because I told them.
And so
or at least I told them what it was a couple of weeks ago.
when you use this app, you check in for every different beer you try.
Every different beer you drink, yeah. Anybody want to hazard a guess the scale of this data?
How long?
So this is 13th of August up to sometime last night. So we're talking 4 months, 5 months? How many?
10,000.
10,000.
50,000.
50,000.
100,000.
A million.
100,000.
A million.
Oh, a million. As of the 15th of December, we've seen 5.92 million check-ins from 370,000 users, drinking 140,000 beers at 330 different venues. So this is, I would say, a substantial data set. This is quite interesting. We didn't expect to get this much. We didn't know that Untapped was quite this big. But this is fantastic. This is fantastic. So now we can start to maybe try and learn some stuff. So the first thing we want to do is just kind of look at, of all of our cities, where is all the activity? Where's all the activity happening? So then we use pandas. Pandas is a decent library for doing data analysis in Python. I use it a lot. And what we can do is very easily set up a data frame, just an empty data store. I can say, oh, I want to store the number of check-ins, the number of users, the number of beers, the number of venues, and the number of days for every city. And then very quickly, I can kind of scan through all of the cities that I have check-in data for and gather up all of the check-ins and gather up all these statistics, all these numbers, and not really statistics, that I want to look at. And what I can do is, with pandas, very easily sort them by any particular column that I want. So if I want to see where the most check-ins are, all I have to do is tell pandas to sort my data by check-ins, and then I can print that out. And it'll give me the answer. So I've cheated a little bit. Here we go. I'll help you out slightly. If I tell you which cities we've been studying: Albuquerque, Amsterdam, Austin, Baltimore, Barcelona, Boston, Charlotte, Chicago, Columbus, Copenhagen, Dallas, Denver, Detroit, and so on. Anyone want to guess where the most check-ins are?
Detroit.
New York, Washington.
Chicago! Chicago has top number of check-ins, ahead of New York, Philadelphia. London doesn't appear until way down here. Okay, so those guys in London really need to get their act together. They're doing this not so well. Where do we get to the next European city? Amsterdam, down here. We can keep Copenhagen way down here. So European cities, not so good. American cities doing quite well. So in the few months that we've seen, Chicago, 513,000 check-ins from 46,000 users. So we're seeing quite a lot of activity out there. Pandas is really nice because, of course, you can sort by any column that you want. I just have to run a cell here because later stuff relies on it. Don't worry about that one. But what if we wanted to have a look at the number of beers that have been drunk? So Chicago's got the highest number of check-ins. Where do we reckon the highest number of beers is?
So the highest number of different
Highest
types
number
of beers.
different beers. So who's got the most unique beers?
New York.
Yeah, New York.
You're all cheating somehow. New York. New York has the highest spread of beers. Then Chicago, Denver. But what's interesting is London's jumped up. So London's got a lower number of check-ins, but a higher number of beers. So evidently people in London are drinking a wider range of beers, but perhaps not checking them in quite so often. So what we can do is we can look at user diversity, right? If we see that London comes pretty low down on the number of check-ins list, but actually a bit higher on the number of beers, we might assume that perhaps the people in London are drinking more beers. They've got a wider variety of beer drinking, and that's why we end up with this higher level of beers in London. So there's a really nice measure that I think comes from ecology. I could be wrong. But it's a way of essentially assessing the diversity of something. It's Simpson's diversity metric, which essentially, if you have a whole population of something, it takes the probability of you getting something from that population. It squares it, it adds all that, squares it, multiplies by itself, adds all those together, and then it takes the reciprocal of that. So it's a way of kind of defining not just the spread of the number of species that you have, but also the relative abundance. And this is used in ecology a lot for kind of, when they go out and do field studies, put a square meter down on the grass and try and decide how many species there are and how diverse the area is. But we can do exactly the same thing with people's beer drinking, right? If we assume that all the different beers you drink, each beer is a species, and how many times you drink it is our population count for that species, we can apply this ecological measure to people's individual beer drinking habits and get a measure of that diversity. So what we can do is for every single user, we can look at how many beers they've drunk of each type of beer and get a measure for their individual diversity as a person. And then what we can do is we can take this by city and kind of assess how many, if we look at the users in each city, how diverse those users in each city are. So we get a diversity measure for each user, and then we look at the cities and see how diverse the users are. And I think I can run this one, another one above. So I've run some code because it takes quite a while, and I have to kind of guess which bit I've run. But what we've got now is a measure of the diversity of every user in every single city. So we can plot this, and we can see how the cities compare. So here's a box plot of the city diversity, and they're all fairly similar. But what we can see is we look at London, and the median diversity is actually lower than a lot of other cities. So although people in London are drinking a wider range of beers, their diversity is much, much lower. We look at somewhere like Amsterdam, and their median diversity is much lower than everywhere else. Okay? So there's something weird going on here. Users in some cities are drinking a wide range of beers, but somehow the city as a whole is not quite as diverse in the beer that they're drinking. And that's a little bit strange. So what we can do is we can have a look at the beer distribution in each city. When we look at London, this is a simple count of every single beer that's been drunk in London and how many times it's been drunk. Okay? And we have this kind of spiky graph. Some beers have been drunk quite a lot. More beers have been drunk less often. We look at Amsterdam, and it's entirely different. In Amsterdam, there is some beer that is insanely popular, and everybody in Amsterdam is drinking that beer. Otherwise, we've got a bit of the same pattern as in London. If we look at our diversity graph, we have a few cities over here which have got fairly high diversity. We look at San Jose, has got a particularly high diversity, just here, median diversity at least. And we look at its beer profile, and we instantly see that it's far more even. Okay, there's far fewer spikes here, so there's far fewer beers that are really insanely popular. Okay, so diversity isn't just a measure of, the range of species. It's not about how many different species we have, but it's about the occurrence of each of those species as well. So San Jose is pretty diverse because we have a lot of different species of beer, but they're fairly evenly spread. So people are drinking these beers quite evenly. Amsterdam is not so diverse because chances are if somebody's drinking a beer in Amsterdam, it's going to be this beer, whichever that one is. So let's have a look at the popularity of beer. Let's find out what that spike is. Python's got these great data structures called counters. I don't know if anybody's come across them before. They're essentially dictionaries, but they don't care. They don't need to know about their keys. So I can go through all of the check-ins in my data set, and I can throw a beer ID at them. And if it doesn't exist, the counter will create space for it. And if it does exist, it will allow me to increment it, which makes this kind of data analysis really, 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 really simple. They've also got a really nice method called most common. So once I've been through all of my check-ins and I've counted up the instances of each of my beers, I can call most common and find the top 30 beers in my data set. And I can print out a whole bunch of information because I've got which brewery they come from, where they come from, and so on. So, in the world, if we restrict the world to 40 cities that we've monitored, that just happen to be mainly in the US and some in Europe, and we ignore, the other 3/4 of the world, what do you think the most popular beer is? Anyone want to hazard a guess?
Guinness.
Guinness, Budweiser, Heineken. All good suggestions. Herein lies the problem with this kind of analysis. The top beer in our data set is Samuel Adams Oktoberfest, because our data set has been collected from August till now, which covers the period that Samuel Adams are selling their special Oktoberfest beer. And with this app being an app where you record new beers as you drink them, obviously the minute this thing gets on the market, people are gonna hit it. But interestingly enough, second, Lagunitas IPA, not one of the big ones. Third, Guinness, great. Fourth, Goose Island, Goose IPA. Fifth, Bud Light. Sixth, Miller Lite. Seventh, Ballast Point. So there's a lot of big breweries in there, right? Coors Brewery, Heineken. I think actually one of these, Lagunitas, is still either Lagunitas or Ballast Point. One of the two has actually been bought out by Heineken or Anheuser-Busch or somebody, so they're not actually as craft. But these are fairly large companies, obviously, right? So ignoring the fact that, obviously we cover Oktoberfest, we need to come back in 12 months' time and see over the course of a full year what the most popular beer is. These are actually all fairly big global brands. Most people who drink a lot of beer will recognize most of the breweries at least, and will have drunk some of them. So let's look at it at a smaller level. Let's look at it at the level of EU versus US. We can do exactly the same thing. We can run through all of our check-ins and just count the ones that are in Europe. So would anybody like to have a guess? Bearing in mind that most people got it wrong. Would anybody like to have a guess at the top beer in Europe?
Guinness.
Guinness. Anybody else?
Heineken.
Heineken. Heineken wins. Guinness in second place. So in Europe, Heineken top, Guinness, Brewdog, London Pale Ale, London Pride. So I think here we're seeing the dominance of London in our data set. London's obviously got the most check-ins, so it's going to really push things. But then we see a whole bunch of European beers, Belgium, Netherlands, Spain, so on. So that's kind of interesting. And just for fun, let's have a look at the US. No prizes for guessing the top one. I imagine it's going to be Oktoberfest again. Oh, I've done EU. Done EU again.
Still Heineken.
Still Heineken in the EU. Hasn't changed. Yeah, there we go. Samuel Adams Oktoberfest, but then Lagunitas Goose Island. So Guinness has dropped. If we're just looking at the US, but otherwise Heineken's dropped as well. But otherwise it's fairly similar. So there's definitely this kind of big split in what's being drunk around the world. And what we can actually do is we can look at this on a city level. So we can take all of the beers that are popular in each city and have a look at the top 5. And what becomes interesting when you look at that is that it's far more local. We look at Denver, and 4 of the top 5 beers in Denver are from Colorado, from breweries in Colorado. London, we've got a bunch of London. We've got Guinness from Ireland. We've got Brewdog from Scotland. We look at Fresno. A bunch of the beers are from California. So Fresno, bunch of local breweries, Washington, D.C., a bunch of breweries from D.C., San Antonio, Texas. Most of the beers are from Texas. Dublin, they're mostly from Ireland. New York, they're from New York, Illinois, Massachusetts. Detroit, they're from Michigan, Massachusetts. So you see that globally, we've got this picture of kind of big name brands and beers. But on a local level, we've got these really local, bottom line, it's Las Vegas. Las Vegas doesn't count. We all know that. We've got these, this far more local picture, right? So in all these different cities, the most popular beers are actually from local brewers, from local breweries. It's just globally, these kind of big name companies dominate the scene. So I'm going to wrap up. I don't look too much at the styles, but the one thing I do want to look at, because it's quite interesting, is ratings. So one of the things Untappd gives us, as well as the beers and the breweries and where they're from, is information on the ratings. So I can go through all these check-ins and all these beers, and I can have a look at how people have rated the beers, and I can have a look at how many check-ins each beer's got. So I could have a look at whether perhaps the beers with higher check-ins are higher rated. I can look at the relationship between check-ins and ratings. And it's a pretty horrible plot. I apologize for that. But it does seem, at least, the beers that have more check-ins seem to be more highly rated. So this social network, this whole wisdom of the crowd thing seems to be working, right? Perhaps. I haven't done any correlation statistics on it. It could all be nonsense. The other thing we can look at is ratings between the EU and the US, because I like the differences between the EU and the US. So we could go through all the check-ins and look at just what the ratings are for all of the check-ins, and look at them between the EU and the US. And what we can do is plot this lovely bar. I should say that most of this code wasn't actually written by me. It was written by somebody else in the paper. That's not to excuse the code. It's not bad code. I'm just saying, I can't take credit for this. But we can have a look at the average rating, and it seems like in Europe we're a little bit more picky. The Americans seem to rate their beer more highly than us.
All Europeans have worse beer.
All Europeans have worse beer, yeah. This is the unfortunate conclusion that I really don't like from this. Yeah, I mean, if we look at the spread of ratings, the frequency of each ratings, it's pretty clear there, right? The Americans are skewed high, and Europeans and blue are skewed low. So either we're all very picky, or our beer is rubbish.
Well, they're just enthusiastic.
Maybe the Americans are more enthusiastic, yeah. And they're like, yeah, this beer is 5 stars, but I've never given 5 stars. I've never marked the coursework at 100%. I'm not giving a beer 5 stars.
It's because you're more discerning.
It's, yeah, let's sound more discerning. But I mean, a beer to get 5 stars, what's it got to do, right? It's got to be an amazing beer. You've got to think like, I never want to drink anything ever again after drinking this. This will be my new water. And yet, there you go. Americans, loads of them rate beers 5 stars, the perfect beer. I don't know, maybe it's a cultural difference. But I like this work. I like this. This is fun. This is something we've been doing, evenings and weekends for a few weeks. And it's taught us some things. There are clearly some cultural differences we need to take into account here. The beer market is kind of hard to assess like this because you can't get every beer everywhere, right? So there's a whole bunch of analysis we've done that's based not around the individual beers, but around styles. And you can see things like English ales are really popular in London, surprise. American ales are really popular in New York, and surprise, in Dublin, the Irish ales are more popular. Okay? But theoretically, you should be able to get hold of a beer of each style somewhere. we've done things where we look at the beers that are available and restricting it to only the beers that are available in every single city, and we still come out with very similar things. The cities have different preferences, they have different ideals. So yeah, there's some interesting stuff about beer. Hopefully, interesting stuff about beer. I'm glad all the code worked. I will say, let me just check. We have a paper. I'm just going to see whether we have a notification. No, yeah. Okay. So this paper may or may not be available in this form at some point soon. But if not, keep an eye out for it because it will be at a conference somewhere soon. We've also got a whole bunch of stuff we want to do. We've got a whole social network. We've grabbed the social network for all these users, so we know who's friends with who, so we can start looking at how beers spread through the network. Is there some sort of epidemic thing going on? Do people recommend beers to each other? We also really want to look at homophily. Are people drinking the same things with as their friends? We really want to look at binge drinking because there's quite a lot of people in this data set who seem to drink an inordinate amount of beer, like worrying call a doctor levels of beer in one session. So we want to look at that. The other thing we can do is look at beer festival event detection. We've noticed already in our data set we get these huge spikes of activity around beer festivals. So there's something to be looked at there, whether perhaps beer festivals link into the social network. Do people go to beer festivals, drink a whole bunch of beer, and suddenly come home with 40 new friends? That would be kind of interesting. The other thing you might want to take a look at, if you are interested in beer, and this is me plugging my own work, is my Cardiff beer monitor, which has now been running for most of the summer. I put it up and then forgot about it and haven't really worked on it since, so there are some problems with it. But it does tell you at any one point what the most popular beer is in Cardiff, what the most popular brewery is, what the most popular style is, where the most popular venue is, and so on. So if you want to have a look at that, then please feel free. And please feel free to email me and tell me when it's broken, because we need people to be on top of this.
That's from the same app, but
yeah, all the data comes from Untapped, yeah. So this is just monitoring Cardiff. Cardiff isn't included in the study because there's not enough people. And it's kind of like, why did you include Cardiff in this study? It's like,
there is that.
I just love it. No, so this is just for fun. But you can follow Cardiff on Twitter, and at some point during the week, it will tell you who the most popular venue was each week and what the most popular beer was each week. It will tweet at you, or it will tweet at the various people. But when that happens depends on when I remember. So there are weeks where sometimes it doesn't happen, like this week where I haven't done it yet. Yeah, thank you very much. That's Python and beer.
Any questions for Martin?
Yeah, I was wondering if you tried to do anything about sort of controlling for the fact that different people might rate beers differently. So some people might use the high end of the scale a lot, and some people might use the lower.
Yeah, no, not yet. It's things we've had in our discussions that we really need to sort out. Yeah, because people do use different rating scales. I, for instance, never got to 5, and I rarely go below 3. And anecdotally, that probably applies to quite a few people. So no, we need to look at some measures to assess that.
There's some quite simple solutions for it. So I've come to that problem myself, and you can design for transformations and things like that.
Yeah, that's something we need to do.
Have you thought
No, please.
Have you thought about contextual analysis? So which breweries are more popular in X and Y place?
Not in this research, no, but it is.
That's something the brewers.
Yeah, it's something I'm aiming to do with PyDiff. So all this is just using the Untapped API that says, give me all the check-ins within a certain area, but you can get the data for every brewery. So you could say, give me all the beers from this brewery that have been drunk recently. So one of my ideas is to create a dashboard for breweries so that the breweries can compete. And I was going to start with local breweries, but I think that would be quite interesting. It's probably, the issue with this is that there's a lot of marketable stuff here. You could easily put together a page showing, competition between various breweries and what's popular in certain areas and so on. But it's all using Untapped data. So the minute I try and start making money off it, I would imagine they're gonna close me down. So kind of keen to fly a little bit below the radar
Unless
until
they,
I can sell it to them. And then,
unless they themselves are.
yeah. Once I've got like a good enough dashboard that I can just say, here you go, here's the code, that'll be X pounds. Yeah.
So it's from mid-August.
Mid-August, yeah.
So can you not get previous data from the API? So is it only like the last 200 check-ins from this?
Yeah. You can only at max. I think you can get 200 check-ins. So yeah, you can't go back in time. So we can only just keep monitoring it. And actually, their API is a little bit flaky on the past stuff. So if you miss data, it's not the way they say their API works and the way the API actually works aren't the same. So it's a little bit tricky to sometimes catch up on past data if things fall over. But, yeah.
One question I've got is that this isn't telling us anything about how people in Europe or the US drink beer. It's telling us a lot about how people in Europe and US who use this app
Yes.
drink beer.
Yeah.
So, which is I don't mean to downplay this. It's awesome. It's so cool. But is there any other data around that you can see or look at to see if what you're looking at here does compare to how
Actual people behave.
Yeah,
Yeah.
is what I'm trying to say.
Yeah. This is a perennial problem in my research. So my actual research that I have been paid to do in the past is not on beer. It's around where people go, and I've done similar sorts of analysis on Foursquare and where people check in. And again, you have the same problem that it's just people who have a smartphone who are in a certain age range who use Foursquare. So the short answer is no.
Could you?
It's quite hard to generalize this to the general population. The work I was doing with Foursquare was looking at personality profiles.
Right.
And we could look at the personality profiles of Foursquare users and look at the personality profiles of the general population and say,
It's comparable.
it's comparable. But without, I guess we could go out and survey a whole bunch of people on their drinking habits. We could get people who wouldn't normally use Untapped to log their drinking. But
What about cross-referencing with, for example, Foursquare and getting check-ins at pubs?
well, that's the problem with their whole venues database is based off Foursquare anyway. So
you're doing
the
that.
same place. Yeah.
Cool. Cool.
So we could look at things like venue popularity and see whether the number of check-ins we've seen at a venue matches the Foursquare popularity. But then all we're doing is matching Untapped users against Foursquare users, which again isn't the general population.
How well advertised is Untapped?
Not at all. I'm guessing. I still can't remember how I found it. It's not. They don't seem to be aggressively expanding, but saying that, the number of users in our database is still growing. So either there's people coming back to the app who haven't checked in for a while, or we're finding new users in these cities. So.
Do you remember how many users you last checked for that?
I can tell you. When we did the paper in August, no, we did the paper in October. That went in. Let's have a look. When we did the paper in October, we had 236,000 users. And we've now got, a couple of months later, all the way back up to the beginning, 370,000 users. So we've got another 110,000 users in a couple of months. So either people are checking in sporadically or Untapped's actually growing quite nicely, particularly in its target market, which is, I guess, the US and the major cities of the US. I imagine they really don't want that information out.
Talking about all the further work you can do, what about incorporating this into some sort of healthcare study? And because obviously talking about big events, the tendencies at A&E goes up on Fridays and Saturdays and at big events. So it'd be interesting to
Yeah.
do that.
Yeah, I mean, just locally looking at PyDiff, the Millennium Stadium makes it into top 10 venues every single time there's a rugby match, and Brains Bitter makes it into the top 10 beers every single time there's a rugby match in the Millennium Stadium, because people are going to the Millennium Stadium and they're checking in their beers, even if it's just Brains Bitter. So yeah, there's certainly some health stuff we can do here. We were talking about this earlier in the pub. When we were talking about ideas for the NHS Hack Day and creating a kind of personal dashboard for health that you could present to the NHS and say, look, here's my Fitbit data, and here's my untapped data. They can assess, okay, right, great, you've been running, but you've drunk 10 pints. So, yeah, there's definitely, I think there's definitely some stuff there.
You have the A&E prepare.
Yeah.
Real-time monitoring
Once the
and tracking.
check-ins are going up on beers, we can, alert we can do this.
Any other questions?
Is it not kind of scary? You mentioned binge drinking.
Mm.
It seems kind of scary. People that are drinking the scary levels of beer are still sober enough to be able to check in. It's not doing what Ian do.
I don't know. Well, there's two answers to that, right? One is you're addicted to live logging as much as me. Have you ever forgotten to check in at a bar? No. No matter how drunk you get, it's habit. But secondly, I think a lot of the people who are checking these beers in aren't drinking the beers; they're tasting the beers.
Of course.
Because you go into BrewDog and you say, I don't know what I'm going to drink, and they'll give you as many tasters as you want until you find something you want, and then you're like, right, great, I'll have 2/3 of that.
So for those people that do take pictures of this, you can actually use it to determine if they're having the 4 pints or if they're taking pictures of these small tasting glasses.
No, but that is an absolutely brilliant idea, because that's one of the quandaries we've been trying to figure out is we don't know how much of the beer we're having. We know that they're having the beer, we know when they have it, but we don't know the volume. So in order to assess how much they're having, we kind of have to make some sort of guess or assumption. And yeah, using we could do a sample of the pictures in the check-ins and maybe come up with some sort of measure.
See how much we see.
So it's a nice idea.
Right, let's stop there. There's loads more questions and we can finish off in the pub. So let's thank Martin. Cool. So the next speaker is Geraint. Whilst Geraint sets up, just to say we're going to have lightning talks at the end. I know one person's giving a lightning talk, but if you want to give a lightning talk about anything or everything, please do. It can just be about anything. No need to prepare. Just come up. Another thing worth mentioning: if you go to the PyDiff website, there's a little news item there about DjangoCon. So DjangoCon last year was in Cardiff, and this year it's slipped my mind where it is. But Daniele, who's not here today, is very heavily involved with Django, and he's offered to help if anyone was thinking about going to DjangoCon and wanted to give a talk. But without further ado, here's Geraint to talk about Q.
Hello. Right, so I'm going to talk about a Python library that I've been working on over the last year. It's called Q. Well, it was only called Q last night. I'll explain why. So this is a version of the talk I'm going to be talking at Python Namibia, which again, Daniela knows a lot more about than me. So first of all, what is Q? So Q is there's a Q network simulation library that it's just a very simple way. You can just input all the parameters of a Q network, run a simple simulation, and then it outputs every bit of data you want from that network. So what do I mean by a Q network simulation? First, what do I mean by a Q? From now on, I'm going to start talking about a Q as a node, because we're going to start arranging the networks. But all a Q is, it's a service center where customers arrive, spend some time in service, and then leave. These nodes can have different attributes. For example, this one of the most simple queues has only got one server. So if the server is occupied, customers need to start waiting in line before they reach have service at the server. The simplest queue in general mathematicians talk about is an MM1 queue. This is when we have exponential pass on arrivals, which means that this time in between two arrivals is exponentially distributed, and exponential service times. This diagram shows the arrivals are passed on with rate lambda, and service times are exponential at rate mu. What I want to show you is that queues don't necessarily behave as you expect them to. If customers are arriving randomly 5 every hour, and customers are departing randomly 5 every hour, we expect not to really have a queue. But what I'm going to show is we do get people waiting, and sometimes for quite a long time. So how would we go about analysing what's going on here? Well, we build a model and simulate it. You can build a model like this using that. This is a model, this is still a simulation. So we could, this is a representation of a system, of the system we want. There are rules which determine how well the system is represented. For example, these Lego figures don't go flying about to the front of the queue. They must wait in the queue. You can use some sort of instinct or a roll of the dice or something like that to determine when these little Lego figures arrive in the queue. And again, how long they spend at service and then leave the queue. And we can look at the behavior of the system, and we can play out what-if scenarios, and we can measure key performance indicators. So for this really crude simulation using Lego, the key performance indicator would be just looking at the queue, how big is the queue. But obviously, modelling like this is really unreliable, it's inaccurate, and very time consuming. It could be quite expensive buying all the Lego as well. So what Q does, Q with a C, it simulates this on a computer cheaply and quickly and accurately. So I'm going to show you now this system here that I'm going back to. I'm going to show you using Q how to simulate this simple node, and show you that if we do get people arriving 5 every hour and leaving 5 every hour, people do still wait, sometimes for quite a while. So I'm going to show you, I'm going to do it repeat the style. Here's one I made earlier. So I'm going to show you now how Q works. So we can import Q this as a library. I'm going to import matplotlib to show you some of the behavior. You need to define the parameters of the system. So over here, number of nodes is 1. So I'm talking about 1 MM1 Q. Number of classes of customer. So we could have lots of different types of customer who behave in lots of different ways. This is the simplest queue, so we're going to go 1 class of customer. Number of servers for each node of the system. I've only got 1 node and 1 server at that node. Queue capacities, I've said that an infinite amount of people can queue if they need to. The arrival rates for customers of first class, class 0, they arrive croissant, which means the inter-arrival time is exponentially distributed, 5 every 10 minutes. Service rates, I said it's exponential service rate, 5 every 10 minutes. And then the transition matrix. This comes, I'll explain this more when I talk about networks queues, but for this MM1 queue, it's just 0 probability of rejoining the queue. I'm going to simulate this for 2000 time units. Yeah, I'm talking about time units because it's totally independent of some like hours and days. Yeah. And then there's this line, detect dead, doctor will talk about later. I've set it to false. So that's a Python dictionary, totally defining the system I want to look at. I can then say, make my simulation object. I feed it in all the parameters from the dictionary. And then q.simulate until max time, I run the simulation. It's running, it's done. This bit, int equals get all individuals. That takes out from the simulation all the customers who have completed service. at some point in the simulation. I'm gonna a warm up of 200, so I'm only gonna look at the customers. I'm only gonna analyze the data of the customers after 200 time units, and then I collect all the weights after the warm up period. Yeah? And now I'm just gonna simply plot all the weights of that queue. And we see that some people are waiting on the extreme end, are waiting 45 time units, even though we have people arriving 5 every time unit. It's quite a long wait. It's not what we expected. We expected there to be no wait. People are coming 5 every hour and leaving 5 every hour. But obviously, because of stochasticity, randomness, this isn't true. So this is one of the most simple things you can look at. What about something a little bit more complicated? This is the reason why I go and use computer simulation to look at networks of queues, because they do get more complicated. Here we have a network of queues. So the important bit here, this bit, is that when a customer leaves a node after he's had service, there's a probability of him rejoining that node or joining one of the other nodes. Here there's a probability R2 to joining the top node again, probability R2 and joining the bottom node, and then the rest of the probability, 1 minus R2 minus R2 1, of actually leaving the system. You can see that the top node there has 2 parallel servers. So again, more complicated things can happen. You can actually have an infinite amount of servers as well, which is analogous to a delay. Then have bottom node. Notice there's a line drawn here. That means that it doesn't have infinite queuing capacity. That means there's only room for N1 customers to queue at that bottom node. What does that mean? That means that if a customer arrives from the outside and sees a full queue, he just turns away and gets lost. If a customer from the top node tries to enter the bottom node when there's a full queue, something called blocking happens, which is quite complicated to analyze mathematically. But this queue, the C, that's really confusing, handles that really well. So what happens here, if I want to leave the top node and bottom node's full, I remain with my server, stopping anyone behind me from starting service with that server, and I wait with that server until room becomes available. And then I immediately jump into the queue as soon as there's room. As soon as that happens, then people from behind me can start can start service to the server. I wanted to show you it's still not that complicated, but this is a more complicated network than before, and the library queue can handle this. So this is what the library looks like. We've got code, tests, documentation. First of all, I'm going to talk about the code itself. What is the simulation? How does the simulation work? Q uses a 3-phase simulation. So if we follow the flow diagram, we start the simulation, and we initially set up the model, we set up the node, we set up the queue, we set up the individuals. We then go to stage A. Stage A means setting the clock to the next event. So that'll be the first arrival at the system. After we move the clock, we go to stage B. Stage B, we carry out these events that have been scheduled. And when we carry out these events, they could cause other events in the future to be scheduled, or they could cause other events to have to happen immediately. These are the C events, the conditional events that happen at stage C. Again, when these events happen, more events could be scheduled for the future, or more events need to happen immediately. So then we check, is there any more C events that need to happen right now? And carry on doing that. As soon as there's no more events to be done at this moment in time, we look at the clock, we check, hang on, is my simulation over? If I haven't reached the max time, I go back to A and move the clock on. And then I carry out all my scheduled events. So this is the standard 3-phase simulation approach used in most discrete event simulation networks. For my code, what are my events? scheduled events that can happen. I have 2 of them at the moment. I have an external arrival, so someone arriving from the outside trying to enter a node. And I have someone finishing a service. And then all other events are conditional events. They only happen because one of these scheduled events has happened. For example, if someone from the outside arrives, that's a scheduled event, and they arrive to an empty node, then they can start service straight away, a screen event. That's a conditional event. What if a customer finishes service, which is a scheduled event, and then tries to enter a node that's full? He gets blocked. A block customer, which is one of the conditional events. Again, more complicated things can happen. If I finish service, which is a scheduled event, I move on to a new node. Not only could I start service to the new node if it's an empty queue, but the person behind me in the queue could then go and start service at this server. So we got 2 start services happening. So this is how all the events sort of pan out and follow on from each other. Eventually I'll show you that we've introduced another scheduled event for one of the extra features of the library. How is my code, how is it structured? Everything is contained in the simulation object. The simulation object is what runs everything. This is made up of nodes, which is what I'm looking at, the 3 nodes I want to simulate. And an arrival node, which doesn't exist in the system, but this is what spawns new customers into the system. And an exit node, which collects all the customers who's left the system, so we can look at all the information of them, or knowledge. So obviously, these individuals can be part of an exit node, an arrival node, or the nodes themselves. And the actual nodes themselves also have server objects. When a customer starts service, an individual and the server get attached together. So they sort of contain each other. And all the individuals carry around all their data records. So when an individual finishes service, he writes a data record of what he did, when did he arrive at that node, how long did he wait, how long did he spend in service, when did he leave, how long was he blocked for, and he writes a data record. And all of these individuals carry on the data records. This project started only about a month or so after I started seeing Python for the first time. And it all started around about a bit more than a year ago now, with me and Vince here sitting down on a computer and programming together, pair programming. Vince, who was an experienced coder, don't mind me saying that, was passing on a lot of knowledge and a lot of skills to me at the time so that I could go and finish the rest of the library. I can't stress how important pair programming was to me as an individual and as a coder and to this project itself. You see a lot of, that's Ambrose going through the Django tutorial.
Oh no, yeah.
You can see us shading a screen, which is quite important. And another one of the most important things was stepping away from the screen, stepping away from the keyboard, and using the whiteboard to plan what we were going to do next.
Like my dog's in there.
Yeah. So I can't stress how important this was for using this project. Of course, this project was all done using Git and GitHub. So I'm not going to go too much into this. It's all on Git for you to have a look at. But one of the most important things I found about GitHub was this feature, GitHub issues. This is quite an old screenshot of the issues. But what was I going to say? These issues tracked what needed to be done. Any bugs we found, and we couldn't just sort them out then, being an issue. And organizationally, this helped a lot for knowing what needed to happen next, who was going to do it. The color-coded labels is also very, very useful. I want to see as little of the red bug labels as I could. Then the blue enhancement labels was an exciting thing, something new happened with the library, so I knew what I wanted to do, what to prioritize my time on, which was quite important for me. So next I'm going to go to tests. Testing was very important for this library. And I don't think anyone likes testing when they first started. But as soon as I started applying tests to a project that I felt attached to, which was cute, you see, I will not write code without writing a test right now because I understand how important it is. So first of all, I did doc tests. This is how I got introduced to testing. You write in the comments, you can write example scenarios, what the code would do, what you expect the code to spit out. And this is my introduction to testing. So you can see some things you had, because of floating numbers, it's a floating point numbers, you have to round things up to be able to make them working. And you can quickly see this gets very, very messy with a lot of scenarios written into the code itself. At one point, I had about 40 lines of tests for a function that just passed. So I ripped all these out and converted them all into unit tests, which is the grown-up testing. One of the things I liked about unit tests is that I can do things like this. So my function, which was essentially the absolute value, I could check, does that do the same thing as another bit of code that's meant to do the same thing, that I know works. This is all Travis, is a server somewhere that runs all my tests for me. Runs all my tests for me every time I push to GitHub, and anytime someone makes a pull request to my library. So that I can look and see, is there anything majorly wrong with what I put, or is there anything majorly wrong with what someone is trying to add to my library. But tests are brilliant, obviously. Tests don't say, yes, the code is right, or no, the code is wrong. What tests do is tell you, has your test passed? Or what if I'm only testing 2 + 2 = 4? I'm not actually testing what Q the C does. So I found from PyDiff last month, I looked into coverage, and this has become my new favorite thing. So it's so easy to install, so easy to run coverage. It runs all your tests for you, checks it against the code you've written, and reports on how well covered the tests are covering your code. And for my library, at the moment, I've got 95% coverage. And some people think that's good, some people think that's bad. What I think is anything coverage tells you is good. If I had 100%, I'd be overjoyed. Yes, all my code's covered. But what I know is, I know 5% of my code is not covered, so I know I've got work to do. What coverage also tells me is which files and which lines in them files are not covered. This is, anything coverage tells you is good news. It just means you've got a bit more work to do. This bit down here of the library is the packaging part, something I wasn't familiar with at all until this week, maybe. So, what's exciting about this is that last night we got this to work, and you can all now go and pip install Q, which is really exciting. You can all use it. We got this to work last night, which meant last night we had to change the name of the library. We had a really cool name for the library called Ask. Stands for Ask Simulates Queues. It was a recursive acronym. I felt really cool. I felt really clever. We looked on pip and it's taken. So we've now gone for Q, which is the Welsh word for Q. It used to be that clever. And now everyone needs to go and do this. Next thing I want to show you is documentation. Last month, PyDiff, we were told how important documentation is. But when I've got other people using my code as well as me, documentation becomes really important, and it saves me a lot of time of telling people how to use my code. I can point them towards documentation. For documentation, I've been using this tool, Sphinx, I hosted on Read the Docs, and I want to go show you that now if I can. So, with the q.read the docs, the most important part of the documentation has got a really cool logo. But this is obviously a work in progress, but I can now click on Getting Started. I can show you an example Kura network. I can explain to you what the Kura network is. I can explain to you how to define the parameters library. Then I can explain to you how to import Q, how to set up your simulation, and how to write all your results to a file so that you can go analyze whatever information you want from the simulation. I can also show you lots of other features. My features page. What features does Q got? Service. I can not just exponential service times. I can look at a variety of service distributions, and this documentation will tell you how to implement them. I can define my own PDF of a discrete PDF of service distribution. And this documentation will tell you how to go about doing that. You can also have customers changing class as they go along, and this page will explain to you how to do that as well. I think this is one of the most important things for when I started working with other people. To point them towards this website and documentation. It saved me a lot of time. So, what's this actually being used for? So there's two bits of work at the moment this is getting used for. One bit of theoretical work that I've been working on along with Vincent and the supervisor Paul, just looking into what happens when a Kura network deadlocks, how we can go about detecting and investigating that. Another bit of work by an exchange student in Valika and a postdoc, Jenny. They were looking at modelling a ophthalmology clinic and investigating scheduling of patients there. So look at the bit of deadlock work we've been doing. What do I mean by deadlock? If you look at this example network here, where there are not infinite capacities, you can see that if all the nodes are full, and the customer at the top node is blocked from entering the middle node, you see if both the customers in the middle node are blocked from entering the top node, then they're all waiting on each other. We have this circular wait going on, and no more natural movement can happen there. The bit of work I've been doing has been looking into how we can detect when this happens and then going on and modelling it. So how do we detect when this happens? We use what we call a state digraph. Each node is a server of the network, and an arrow is a blockage relationship. For example, the customer at A1 is blocked from entering B, so A1 has arrows to both the servers of B. And the thing highlighted in red is called a knot. And whenever you get a knot in your state digraph, you have deadlock. This was implemented into Q, and to do this, we had to adjust the code slightly. So we had to create servers as objects, which I showed you earlier, but we didn't have that before. We had to attach customers to the servers whenever they started service. And whenever anyone got blocked or unblocked, we had to keep track of what the digraph was doing. So the simulation itself has an attribute called state digraph, which keeps track of this. Then I had to detect when the knot was happening, which is another method. And I now have a method which I can create a simulation. I can go simulate until deadlock. As soon as I get deadlock, then it returns to me how long it took to get to deadlock from each different state of the system, from each different configuration of customers in the system. From this, we got results on the time to deadlock. So I said, as for a one node system with a feedback loop that could reach deadlock, as we change the service rate, how does the time to deadlock get affected? We get this nice curve. Or you can see as I used my library to get all the data for the violin plots, which show you the distribution of the time to deadlock. And what was really nice was that that matched exactly with the analytical models I was building independently, and very proud of this graph. The other project that's going on that Nico was working on, modeling the ophthalmology clinic. What she was looking at was we had customers arriving at the clinic according to a schedule, which was just simply one every 15 minutes. It was very simple to implement in code. We had 3 different clinics, but they all had different opening times. Then they exited, and they had a chance of getting delayed by a varying amount of time before having a follow-up, which is joining the queue again. What was important here was the schedules of the servers. The queue, before this, queue didn't have that functionality. So we had to implement this for her, together, for her to be able to look at this. So if we look at the documentation, assigning work schedules to servers, this was all known, this was all tailor-made for Lika, but again, general enough so that anyone can go and use it. If you can assign a schedule of how many servers and at what times then that servers are on. And again, this used the functionality that I had before of having a server as an object, and we were attaching customers to servers. So it worked out really nice. They already had that in there from my deadlock work. That Lika could then implement this. And that's about it. I want to obviously thank all the people and libraries I've used, because without any of them, none of this would have happened. Obviously, go and pip install my library.
Any questions for Geraint?
Can I ask for something? Does Q stand for?
No. I was trying to find a really cool acronym for it, but it's not. It's just the Welsh word for Q.
Q investigates weights. What's wrong with that?
It's alright, it's okay.
What's one of the most sort of complicated simulations you've run?
So the whole point of this was that any individual simulation is really simple to run. You just put in the parameters. But the feature that was most complicated to put in was the blockaging. The reason for that, which is the reason we went on to investigate deadlock, was because I couldn't tell if the blocking was working, because the numbers I was putting in was making a deadlock all the time. I didn't know why. Yeah.
Have you considered any real-time monitoring of queues and queuing systems?
This doesn't do that now at all, but if you want to simulate a real queuing system, you do monitor, and you take that data, from that data extract the parameters to be able to then simulate it and run your what if scenarios on that system.
How do you break a deadlock when what happens?
That's the next bit of work to do, but I think it's just kicking people out at the moment, but I'm not sure. We'll see.
You've thought about visualizing this as well in real time, so taking your model.
That's not in real time, but visualization is an issue that Vince is going to be working on next, right?
No, I'm gonna display the network, but then actually visualizing it so you're seeing the people move around. Yeah, you could do it 2 ways, because with your data set, you could just have another library that just runs through a data set and visualizes it, which is probably the nicest thing to do to keep everything separate, but otherwise you could certainly also just have the visualization on top. But I would vote for just visualizing the data set, really, because then it's nice and unique. So. Yeah, I thought you'd sign me up for something very difficult then. I was like, no, I'm just make a network and I just want to look what it looks like. Great, let's thank Geraint. So So we've got some lightning talks lined up. I know, Adam, you're going to give a lightning talk. Who else? Does anyone else want to give? Yeah, awesome, great. Don't break everything. Cool. Come on, come. Pick who wants to go first. And...
Thank you. Yeah, leave now, Alex. This could be awful.
Get yourself set up. So, can I just ask if everyone was able to find out about? Oh, you're here. So, how are people finding out about?
Ambrose told me.
Ambrose told you. Is that the same for everybody? I told Ambrose. Okay. So there's a website. There's a meetup site. There's a Twitter account. There's a mailing list. There's a Gitter room. If anyone could suggest any other way of letting people know.
Don't think there is.
Just yeah. Just let me know. But please tell people it's really great that that there's so many people here before Christmas. It's awesome.
Well, he's getting set up. I talked to someone new. Try presenting this at Fosnet.org. It's a very big conference for free. It's a free conference for open source developers in Belgium. It's coming up.
Daniele is asking to see everyone. Does anyone mind if I move the camera around? No. Everyone, wave at Daniele.
There's a lot of very.
Geraint, wave at Daniele. I'm assuming he's waving back.
How's Daniele contacting us? Is he typing to you?
Yes, he's talking to me on. Yeah. Right. So Adam, you know the rules. You got 5 minutes.
I hope this fits. Could either be awful.
I'm going to try and see if I've got a timer on my phone.
Oh shit, where's it gone? Just like pop up there.
Whenever you're ready.
Right. So after last month's inspirational lightning talk by Alex, I thought to myself, how could I do? What would my code journey be like? And mine's pretty boring, really. It started when I came here, thanks to Vince. Thank you. And then this code club, which Vince was brilliant at deciding to do this year. And so I decided that this is what my talk's going to be on. Evolution of Code Club and the results of website. Now, how did it all begin? Now, Vince, our brilliant lecturer, it's pain to say this, just
you're not being recorded.
Exactly. Came up with the idea after his first year's module, maths, went so well that, well, why not have a code club where people can get together and talk and do stuff. So Vince goes ahead and he creates this library, or this repository on GitHub. It's pretty boring, there's not much to it. This is the website. As you can tell, it's not great. So me, Alex, Tim, a couple of regulars, I think, come along and we did some extra stuff. We couldn't think of much. So this was after the second one. Vince loved that because he tried to teach me Vim and I hated him for it. So yeah, but I wasn't happy with this. So unlike a couple of the other people and going to a bar and doing stuff, no, me, Alex and Tim, we go to the library and we think, right, what can we do? What can we do? We go, why don't we do a sessions page? We'll do the best quote from each session. And that's what we come up with. What I like to call sessions page version 1.0. It's a bit shit, but hey ho. Then what did we have? Oh yeah, Alex went on a bit of a mad one and decided to create a whole sessions page, the whole background for the website, which is the inverse of what you can see is the background of this website, the slideshow. And it looked a bit like this because the idea was that all the text was going to look like a terminal, but we weren't that good yet. We couldn't get it that far. So we started here and we thought we'd go along as we go. However, we had a major problem when it came to the mobile side. As you can see, it's not great, but you kind of can't see here. It goes away on the menu. It's not brilliant. So Vince goes, oh, there's this kid called Toby. He's good with Bootstrap. He can come along and do stuff. So yeah, this happened. He came for, what, 2 weeks, I think? Did 5 commits, and the repository went from this size to this. And the website went from this to this. It's awful, but hey, it works on a mobile now, so who cares? So Tim, who is now the resident, code janitor, came along. He did a couple of extra fun things with CSS, and this is what we got out of it. Looks quite nice, I thought, personally. And me and one of the other people who's not here, sadly, came up with a list of contributors, and we came up with random names for them. Now, I'm known as the flamboyant coder because for the whole of last year, I spent redoing and making my own theme for an editor called Atom, which Vince got me onto, and I'm now loving Atom because of this, because of the customization. Alex is the real coder because, as if he came last year, he knows everything. He has since from that one, from last month's thing, been changed to Leonardo because, as Vince goes, he's touched everything to do with code. Sessions page 2.0. This, as you may have noticed, sessions page is kind of my baby when it comes to this because I love the session. Vince goes to me, well, we've got this at the moment and we want something a bit different. So using SlickNav and his GitHub page, I came up with this, oh God, where's it gone? There, I came up with this. So Easter last year, why is he not showing it? Vince? Why is this not showing?
I don't know.
Screw it, I'm not that close. Maybe it'll show. Showing now? No. Why now? Is it not showing? I don't actually know why it's not showing.
You got 10 seconds.
I know. Yeah, well, basically, the website comes up. It comes up with a drop-down menu and all that jazz. Basically, where's it gone? Yeah, and then. Sorry, this is awful. Any questions?
Thanks, Adam. Any questions for Adam?
No?
Take a look at the Code Club website.
Yeah.
Students have all been great taking that on and making it their own. So, Ambrose, you're next.
Yeah.
Which way are you going?
Do you need my laptop?
Yes.
Don't die. Okay.
Yeah, that was really rushed.
I mean, that's still plugged into that.
Yeah, I know.
That's cool. I don't really know what to do this. So.
Where's the memory stick?
I have it. There we go.
Thank you.
The PowerPoint one.
What am I putting up PowerPoint? You're putting up the.
I don't know how you use this stuff, so just.
When you put the PDF on there, it's what I told you to do.
The PDF is also on there. So what do I do here?
You go find the PowerPoint on there because I haven't got PowerPoint on there. Child, seriously.
Me no good computers.
Close Steve.
Yeah.
Seriously.
Don't worry. It'll come up when it comes up.
At the same time.
It's probably data.
Is it data? No, it's not
No,
data.
it's not data.
It's working.
Why is it not working?
I don't need the PowerPoint, I suppose.
Kind of do.
I mean, no, it was just for looks.
Is it on your computer as well?
The PowerPoint?
Yeah.
No.
Do you want to just plug in that?
Yeah.
It's not on there.
Hold on.
I
Hold
wouldn't bother
on.
about it. Yeah. Literally, the PowerPoint
Give me
was
2
just as a
seconds.
look. What? Will that run the PowerPoint?
No, but
Right, good.
do something else now.
So the next the next PyDiff is on the 19th in January. So we've already got one speaker. If you take a look at the website, you can already find it up. I'll put it up on Meetup, etc. Ed Gomez, who does some cool stuff with Python and telescopes, will be speaking. But we're sorting out a second speaker. If anyone would like to speak, get in touch with someone. You know, you can tell because it's a friendly audience.
Yeah, I know it's not. It's this. I don't know why that is like that. Okay, I don't know. That's the problem I had earlier. You sure you're all right with that laptop there?
That's fine.
Yeah. Right. Just press the space bar to go through.
Oh, wow, that's pretty cool. Alright, for the sake of it, I literally finished this an hour ago. I finished I haven't actually finished it, I just sort of gave up and it was too late, so. Right,
Got 5 minutes.
5 minutes, yeah? Ready? Alright. Hello, my name's Ambrose Law, like Ambrosia Custard. Custard is defined on Google as, where is it? A dessert of sweet sauce made from eggs and milk. It also gives us on Google a breakdown of what's in custard. So as you can see, there's 51 milligrams of cholesterol, all that kind of stuff. But what else we can see here is that it just takes a load of different results which you can find when you just type in custard. That's all I do is type in custard. Now, what we see is recommendations. Recommendations are basically Google just taking information from all my past and everything like that, all the stuff I've Googled over the years, and I've started to collect the data of it, collect some kind of system, and refining what it thinks I want to see. So as a comparison, this is a picture of my friend in Norway's, what his custard result finds. As you can see, it's slightly different, it's all different from the other ones, but only 1 or 2 of the results are the same, everything else is different. So Google is basically searching for us, so we don't actually need to. But it doesn't really know what we really want, because it's only a machine, I hope. But your privacy on Google is a very large debated aspect of when you access and what you type in, and all your all the information which Google can track from you. You never obviously tick the box when you go into Google saying, I'm happy for you to take all of my information, but in a sense, when you use Google itself, you've already agreed to allow it to take some information and gather information on you, especially if you make an account where then you have information like your emails and things like that stored onto it. It's just going to keep gathering more and more information you over time. And so basically, if you don't like Google getting information on you, there's a few things you can do. Well, there's a few things you can try to delete everything, but there's always argument, there's always going to be bits of you there. Or you can just get a new site by using Yahoo search engine or Bing search engine, but they're just going to get more information. There's a lot of effort to just run Facebook, really. So Facebook is another way where the internet just compiles data from you and uses it to recommendate and bring adverts and sales and things for yourself, and sell it to companies so that they have ad space to try to sell to you to get more money. I personally, I use Facebook, but I don't like a lot of things. I don't share a lot of things, but this doesn't actually make me invincible to Facebook. Facebook still gets information from me. So how can I do this and try to not get information stolen from me? To do this, we can, so either I can use Google to basically just take me on a tour of all the things I want, all the information that's gathered, or Tor browser. I can use Tor browser to basically encrypt my information, encrypt my data, and able to use it to go places where you might not want people to know you've been, which is the darknet, which you can search Facebook now. So Facebook has done a big thing with Tor, trying to make it that Facebook can actually work in Tor. For those who don't know, Tor is basically you can use it to encrypt all your information, and this has an issue with Facebook when it's trying to pinpoint things, and it's just being sent all around the world through different servers. As a result, they said the quote from them is, "You get around the censorship and local advertisement surveillance, and it adds another layer of security on top of your connections." Which, at the end of the day, they're still going to take a load of information, and you're not safe from your information being taken from Facebook, but you're safe from all your other viewings influencing what you see on Facebook. How long do I have left?
Oh, 40 seconds.
That's good. So I'm just going to, I didn't realize how long this was going to be. This is my first time doing this. So basically, what this gets to is there's a load of different algorithms which are able to pull from your searches, compile it into something or other, and is able to spit out the other side recommendations for you. It's always just a load of recommendations. And using these algorithms to compile and take information from one place to another, there's lots of different funky, fancy things with coders have been able to do over time. One of these things is, there we go. Yeah, missed that a lot actually. You know, I'm going to stop there because I didn't realize how much time I needed. So, right, yeah, I'll stop there. So basically, I had a little bit more to get, a little bit more, but unfortunately, I don't think it's going to do it justice if I squeeze it all in the last 10 seconds. So I'll come back to this.
Thanks, Ambrose. Thanks for telling us about Tor.
Yeah.
Any questions, Don?
It was nothing new, I suppose, to most of you guys.
No,
I'm sure most of you use computers. So.
I'm sure some people didn't know about that. So yeah, thanks.
Yeah,
thanks, Adam. Thanks, Ambrose. Thanks, Martin and Geraint. And thank you all for coming. We're all gonna, well, some of us are gonna head to the Pen and Wig now. Hopefully, please do join us. And if not, stay in touch. If there's a better way of getting in touch with you, just let me know. And we'll see you next month. If you'd like to speak, come chat to me as well. Thanks a lot, everybody.